Hello and welcome to my channel. I'm Akram and watching Knowledge 360. In the previous video, we discussed about JSON data types, and in this video, we'll discuss about array data types. Arrays allow a column to hold multiple values, and PostgreSQL supports array of any built-in, enum, composite, range, or user-defined data types. So let's declare arrays in tables. How we do it? To declare the array, we can append the square bracket to a type or using the array keyword. We can specify dimensions, but PostgreSQL doesn't enforce them. So let's create the first table. Here we are creating one table called salary employee, and the column pay by quarter is of integer array and it is one dimensional array, and another column is schedule, which is a text column, and we have defined it array, and this is two dimensional array. So let's create this table, and the table is created. Similarly, we can create another table called tic-tac-toe where we have defined squares as column and the data type is integer array, and this array is two-dimensional array and the grid is 3 cross 3. So we are defining this, but this is not enforced. So let's create this table. This table is also created, and there is an alternative SQL standard syntax as well, that is using the array keyword. So we can create another table, and here we have column pay by quarter and the data type is integer, and then we have mentioned the array keyword and then the 4, that is the length of the array. And similarly we have another column defined which is a float data type and is also array, so that means it is a floating array. So let's create this table as well. So this table is also created. Now let's insert data into the arrays. So there are multiple ways to do it. First we'll do using the curly braces. So first we are adding one employee called Bill, and this is the pay by quarter and this is the schedule. So let's insert this data. So this data is inserted, and next way is to use the array constructor syntax. So let's create another employee, that is Carol, and we insert the data for Carol as array, and then the square bracket within that we can mention the values. Similarly for two-dimensional array as well we can do like this. So let's insert this data as well. So this data is also inserted and we can view the data from employees table. So here is the data that we have inserted. So here you can see that even if we uses curly braces syntax and the array constructor syntax, but the data is stored as curly braces only. Now let's see accessing array elements. In PostgreSQL, array indexing starts at 1 by default in PostgreSQL. So first example is like this. We are querying from the salary employee table where the pay by quarter first element is not equals to pay by quarter 2. So that means the quarter 1 value is different from the quarter 2. That means the amount changed. So let's query this and see the result. So this is the result. Now let's do another query where we are fetching the third value of the array. So let's execute this query. This is the name of the employee and this is the amount that are paid. Now let's see how to get the array dimensions and length. So to get the dimension we use the array names. This is the function and then the column name, and for array length this is the function and this is the syntax. So let's query for this the employee Carol. Let's say the dimension and length. So here we can see that the first is the dimension is 1 to 2 and 1 to 2. That means this is the two dimensional array and the value should be 1 to 2 and the length is 2. Now let's see modifying array values. So we can replace entire array as well. So in this case we are updating the salary employee table and the pay by quarter value we are changing for Carol. So we are setting these new values. So let's perform this update. So the update is completed and we can verify the data. So here you can see that the pay by quarter value for Carol is changed and the entire array is replaced. Also we can update the individual elements as well. So in this case we are updating the fourth element of the array for Bill. So let's update this data. So the data is updated and we can verify that. So for Bill, if you see the fourth element, that is changed now. Now let's see what will happen when we add elements beyond the existing length. So in that case the intermediate elements becomes null. So in this case for Bill we are updating the sixth value as 18,000, but we know there is no fifth value. So let's see what will happen. So the data is updated and now query this, and here we can see that for Bill we have the sixth record as 18,000 but the fifth record is null. So as we know that intermediate elements becomes null. Now let's see array concatenation. There are multiple ways to do it. First we'll do the array concatenation using the pipe operator. So let's combine two array, that is array of 1, 2 and then array of 3, 4. So the result will be array of 1, 2, 3, 4. So let's see the result. So here is the result. Similarly we can combine nested arrays as well. So in this case we are having these two arrays and we are combining them. So let's combine this 2D array. So here is the result, and we have combined the arrays using the pipe operator. Also we can combine the arrays using the array functions. So here is the function called array append, and we can append the array, that is 1, 2 and the second array is 3, and we can combine the array and we can see the result. So here is the result. And there is one more function called array prepend, which will prepend the array elements to the existing array. So this is the syntax of writing this function, and let's see the result. So this is how array is appended. And there is also another function called array cat, and here we can combine the array in this way. So let's execute this one. This is useful for 2D append. So the array is appended. Now let's say searching in arrays. First is matching any values using the any operator. So in this case we are querying from the salary employee table where 10,000 is any pay by quarter. That means in the pay by quarter, if there is any value 10,000, that record will be reflected here. So let's execute this query. So here we can see for bill we have 1, 2 and 3 values which matches the 10,000 value. So in this case, even if there was only one 10,000 value, it should have returned. So this is the way how we can match the value using any operator. Now let's see match all values using the all operator. So in this case, let's update the value for Carol first. So the value is updated and the array is replaced. All the values are now for Carol is 27,000. And now we can perform this operation. So in this case, the all operator will check if all the values are 27,000 or not. So let's execute this one, and here we can see the result for Carol. This is written, and we know that all the values are 27,000 for Carol. Now let's see position search in arrays. So in case of array position example, we are searching Monday in the given weekdays. So let's see what is the position for this string. So here we can see the position is 2. So as we can see in the array, the Monday comes in the second position. There is another function called array positions where we can find the multiple positions available for one element. So in this case, we are searching for 1. So we can see how many times 1 appears in this array. So let's execute this one first. So here we can see that 1 appears in the first position, fourth position, and then the 8th position. Now let's see one bonus example. Arrays in functions. Use unnest function to loop over arrays in queries. So this is how we can write this. Select unnest, then array is passed as pay. So let's execute the query and see the result. So here we can see that array elements are turned into the records. So here is an example of using of arrays in stored procedures or composite functions for advanced operations. So here we are creating one function that is called sum array elements, and the parameter is one integer array. So in this case, we are passing one array into the parameter and we are looping through that array and we are making the sum of the values. So let's create this function first. The function is created. So now let's call this function. So when we call this function, we are passing one array as parameter to this function. So this function will make the total of the individual elements passed in the array. So let's execute this query. So this is the output. So the conclusion is arrays are ideal for representing grouped or repeating values inside a single row, and it is good for small bounded data structures. Use array functions or operators like any, all, unnest, array positions, etc. Arrays offer flexibility, but always evaluate if they are the best fit for your data model. So this was all about arrays in PostgreSQL database. If the video was helpful, do like the video and subscribe the channel to get the notifications for upcoming videos. In the next video, we'll discuss about domain data types in PostgreSQL. So let's meet in the next video. Till then, take care. Bye bye.